Hi, my name is Ram. This is going to be my talk about Visi Data. Visi Data is a cool tool I've been using lately to explore tabular data. It's a very cool tool. I'm going to tell you all about it. I've got here a link to the VisiData's website and a link to my slide deck. Okay. Hi, so my name is Ram. I've been a contributor to the Python ecosystem for many years now. I authored a bunch of popular projects like PySnooper and Python Turtle. I contributed to a few popular projects that you know how, and I'm a fellow of the Python Software Foundation. So I've been working many years as a software engineer. A few years ago, I guess 3 years ago, I found a very interesting research problem in AI that I found very interesting, and sort of like started working on it in my spare time, and it took over my career. And I'm now making a career change to be a researcher. So super interesting problem. I joined Bar-Ilan University, and my research is funded by Alter, and it's really foundation in the effective altruism space. I've got a link here to a mailing list where I post monthly updates about my research. So this talk is not going to be about my research, but about a tool that I found while doing my research, a tool which I think is very cool and useful. So my research is about, my goal is, I want to take a bunch of AIs, and I want to put them in the same room together, and I want to see if they can become friends. I mean, I want to see if an AI seeing another AI could have the realization of, there's another person here that's like me. Maybe I could be nice to them, and they're gonna be nice back, and we're gonna do things together. So I thought of this problem a few years ago, worked in my spare time, and now I've just gotten deeper and deeper into it. Let's look at some data. So I run experiments in which I let a bunch of AIs play a game together, a game time makeup, and I measure the score that they get. They try to maximize their reward, and I measure the interactions with each other to see if there are any interesting social behaviors. So this is an example of data from one of my experiments. So I'm going to switch to doing without a mic because I need both of my hands. Okay, so this is an example of a data file that I might use from an experiment. And in this data file, I have it's a CSV, and I have two columns. I have a generation, meaning a generation of training, and I have the reward for each episode. So when I look at this file, I can kind of see what happens. I see that at the beginning of the training, they get 230 or 250 points, and then they train. And then if I scroll down, I see they get 282, they get 300 points, 20 points, and I can see that they're improving. And gradually, I want to see what happens in the experiments. So I keep adding more metrics. Right? This is another file in which I've added a metric called n-completed skirmishes. I want to explain what is some metric about the game they're playing. And I can kind of see the result. I mean, this isn't the best way to see the result. It's a text editor, but it kind of works because I can see they start at 23, and later they learn and they improve, they get to 25, and they get to 26. So I can kind of see what's happening. And then I add a couple more metrics to get a better idea of how they behave. And then I add a few more metrics. And at this point, I understand that I can't use a text editor anymore. I need a serious solution for viewing tabular data. So, I mean, I know that I can take this CSV file and I can open it with Excel or with Google Sheets or with Jupyter Notebook, or I guess even VS Code or Tableau. But I don't like any of these solutions. I mean, I want something very lightweight. I don't want to open Google Sheets and do a file import and then have a sheet that exists forever in my Google Drive. I mean, I don't want to touch the mouse. I don't want to start a process. I don't want to start a Jupyter server. I want something very, very lightweight. I want a solution I want to see a table in a nice way. I would just want to press a button, see a table in a nice way, be able to do all kinds of manipulations on it, and just have it be very, very lightweight. So I asked online for such a solution. Someone said, use Visi Data. I tried it. I didn't like it. I thought it sucks, and I hated it. I asked again. Someone gave another solution. I didn't like that either. So I tried Visi Data again, and then I fell in love with it. This is what it looks like. Okay, first I install it. Pip install Visi Data. It's an open source tool. And it's installed. And it looks like this. Okay, this is the same data from before. I really like this, and I have lots of feelings about that. I mean, it's nice that it's sort of like it's a sort of low-tech solution. It's a program that's in the terminal, so it kind of looks like something old, but also it definitely looks modern. So for me, this is it's a very nostalgic screen to look at. So personal story, I got started with computers when I was a child, and when I was a child, my mom had this program on her computer called Lotus 123. Lotus 123 is what people used instead of Excel in the 80s, late 80s, early 90s. Right, so when I was a kid, it amused me to open a new spreadsheet and play with it. So it's nice for me to see that a modern program that looks like this is still useful. So this is now kind of like a spreadsheet. It is kind of like Excel in a way that I can move around and I can, I don't know, delete rows and columns, and I can edit rows and put stuff in them, and I can do a search, right? Let's talk a bit about pros and cons. So I like that it's lightweight, right? It's in the shell, so naturally it's a very lightweight program. The fact that it's in the terminal means I can use it via SSH, which is great for me. Like if I've got some kind of data on a remote computer, I just SSH to it, pip install Visi Data, and it's there, which I like very much. Everything is done with the keyboard. I'm a keyboard guy, as you can see, and I like doing stuff with the keyboard, so that's huge for me. Everything is very low friction, and I'm going to show you that later. It's open source. Let's talk about the disadvantages. Because everything is with the keyboard, if everything is done with the keyboard, you have to memorize lots of key bindings. It's basically like another Vim. You have to go through the thing where you have to learn them one by one, which is frustrating. It isn't meant for big data, right? It craps out at around 1 million rows because it loads all the data into memory. And it doesn't have as many features as Tableau or SQL. It's more of a fun, lightweight tool that does have lots of features, but not as much as these solutions. Oh, by the way, I forgot to say, feel free to interrupt me during the talk if you have questions or anything. I'll be happy to talk. Okay, I want to show you a few of the different data formats that VisiData can open. So I've shown you a CSV file. Let's see a JSON file. This is some tabular data in a JSON file. So I've seen this kind of data a million times before. It's a nightmare. I hate it. This is what it looks like in VisiData. Right? A lot nicer. Just the fact that I can see everything a lot easier here.
How do you tackle the nested JSON? No, it's wrong, but
if it's nested in a nice enough way, it's gonna show it as a group of columns, like a column which is a group of columns, and which you can then expand. I actually do that in my experiments when I want to cluster some data into folders, sort of. So I can load JSON files. I've got an Excel file here. I can open an Excel file, right? This part of the talk actually makes me nostalgic for something else. I don't know how much of you guys used to watch YouTube around 10 to 15 years ago. There was this series of videos, which is a commercial, Will It Blend? A commercial for a blender. And like the idea that every episode he would take something weird and he would put it in the blender and show how the blender is able to blend it. So this is what VisiData feels to me, because I'm going to show you a bunch of formats that are not supposed to be tables, that are made to be tables. So I've shown you a CSV file and a JSON file and an Excel file. I've got an SQLite database. I can just load it up, bunch of tables in it. I can go to each and every table, and I can see the data. I can also do joins. I might demonstrate a join later. There is support in the works for MySQL and Postgres. Let's go back to things that shouldn't even be a table in a way. I'm going to open VisiData without an argument, just like that. And what it does basically shows me the files that I have in my folder. And I can go into any subfolder and see the files there, and I can go back. I mean, to the older people here, it might remind them of a Norton Commander, right? Which is a lot of fun for me. I mean, I like seeing all the files that I have. I can open a text file, no problem. It can open a PDF file. It can open a zip file. It can open the files inside the zip file, and it can open a PNG file and show me all the pixels. Is it useful? Probably not, but I still think it's cool. And I can ask it to give me some insights about it. I can say, I want to see some insights about the pixels in this photo. I can see there is red, green, and blue, and how many of them, and what is the mean. I can see the mean for red is higher than the green and blue, so the picture is red. Again, not super useful, but we slowly starting to see how VisiData can show me insights about the data. This is the kind of complete list of formats that VisiData opens. As you can see, a whole bunch I didn't get into. Okay, so let's talk about what I've talked about and what I am going to talk about. So I explained what VisiData is and shown a few of the formats it can open. Let's talk about getting some insights from the data. And then I'm going to talk more about the philosophy behind VisiData. And then I'm going to show more advanced insights. Let's open a file. I've got a file with data about stocks. This is a file with data about stock movements in the year 2017. For a bunch of companies, on every day on that year, the price in which that company opened and the price at which it's closed. I can do a frequency table on the company to see the companies that I have. Now, I know I'm going to do a bunch of things here. I know you can't see my keyboard. You can't see exactly what I'm doing. It is confusing. One thing you can see is that in the bottom right of the screen, it says the key that I just pressed. So if you're wondering, what did I just do? You can look here and see what I did. Shift F is a very useful shortcut which opens a frequency table, meaning that when I am on a column and I press Shift F, for that column, it's sort of like, I guess in the next school, maybe it's called a group by. Basically, finds all the different values for that column and groups all the rows by them. So I can go into any of these companies and see the data for those companies. Let's go to Berkshire Hathaway and say that I want to see the stock movements for Berkshire Hathaway. So I could do something like this. Now I have a plot for the stock price for Berkshire Hathaway, right? So this is awesome. I love this. And you might be asking, how is this in the terminal? I mean, it kind of looks like ASCII art, but not exactly ASCII art. Can anyone guess how this was made? What?
Using the special deltas at the end of the ASCII table with the...
Yes.
One of the 100,000 special characters. Yeah, it's Braille characters. Braille characters used for... used for vision impaired. I'm not sure how they are supposed to fill it on the screen, but it works. So basically, it's sort of like we use the Braille characters to make plots in the terminal. So obviously, these are not plots I would use for publication, but the fact that I can create a plot without writing any code, just on the command line, a few clicks of buttons, and I see the plot is super useful to me, right? I look at lots of experiment data, and I can visualize it very quickly. And I can even, because there are two groups here for high and low, I can toggle the high and the low and see only a certain group. I want to dive into plots a bit. I've shown you my experiment data from before. This is the file I've shown you in the beginning, and I was talking about the episode reward, and now I can very easily plot that and see how my agents learn over time. All right, so this gives me a very good idea of the behaviors of my agents. I want to show another cool example for a plot. I've got a data set of all Walmart stores in the US, and including their location. So I'm going to set the longitude as a key column, and also the state. Key column, in a way, is sort of like the x-axis of the plot. And now I'm going to plot the latitude, and it's going to look like that. So now I'm looking at all the Walmart stores in the US, and I can even toggle them by state. Here's Texas, here's Florida, here's California, right? So I really enjoy that.
How did you make the shape of the US?
Walmart did that.
Oh.
They just gave the longitude and latitude data for their locations, and then just made a plot of it.
The Rocky Mountains is not so many Walmarts.
Right. So I want to explain a bit, because I know it's a bit jarring when I move around the program. So when I'm on let's say I'm on a sheet like that, and I open let's say a frequency table, like this one, whenever I do that, I sort of open a new table. It's like opening a new tab in Chrome. And now I'm doing stuff on the new sheet, but I can always press Q to close this sheet and go back to the sheet I was on. So it's like there are tabs, and I can press Shift S to see the list of all the sheets. This is called the Sheets sheet, and it's also a sheet. So that's part of the VisiData philosophy, which is very important. So everything is a table. Sometimes I would say table, sometimes sheet. Everything is a table, and a big part of the VisiData philosophy. Let's talk about the philosophy. I'm going to talk about a bunch of philosophies, but everything. It's like the idea is let's make everything into a table, and then let's provide great tools for analyzing tables. This means that when I use VisiData, I've shown that even the frequency tables are tables, but even if I go into the help menu for the program that shows me the list of all commands, even that is a table. So I can go here and I can, I don't know, delete rows, not that it helps, but I can say, hey, I want to search for a command that, I don't know, does something with columns. So I search for column. Or I can say, I want to see only the commands that have something to do with sorting. So I'm going to press the command for selecting all rows that say sort on them, and then make a new sheet with only the commands that say sort. So the point is, once everything becomes a table and you know how to handle tables, you can move through a lot of things very, very easily, which I really like. So there was one. Oh, I made a meme. This is SQL. This is VisiData. So that was one sort of philosophy of VisiData. Another one is ask for forgiveness rather than permission. Right? When I've done stuff in VisiData, and I'm going to do a bunch more, every time I did something, immediately saw something happen, and if I didn't like what I saw, I could go back. So which seems kind of trivial, but if you were doing the same kind of analysis in SQL, you would be writing a long query, and you wouldn't see what's happening while you're writing it, and maybe it wasn't what you were imagining. The fact that it feels like I'm really touching the data with my hands, and I can feel every move, and if I did something wrong, it's okay, I just go a little bit backwards. That is something that I enjoy very much. So going backwards usually means either doing undo with Shift U, or Q, just closing the sheet if I open a new sheet that isn't useful to me. The last bit of philosophy I want to show is the composable command keys. Again, this is similar to Vim in a way. There are lots of key bindings that you have to remember, but lots of them have sort of logic to them, as in, if there is a G before a command, it means make it bigger, right? I press a dot to plot a column, G dot plots all the columns. The same logic applies backwards with Z. Z makes things smaller. Y copies a column to the clipboard, Y copies only a cell to the clipboard. So I know that the fact that there are so many commands and keys to remember, I know it's intimidating, and there is, I mean, it is a problem. I know, and it makes you feel like not really learning it because there's so much to learn. What I did this tutorial here. It's a pretty long tutorial. I think it's like 10 parts. It teaches you a bunch of shortcuts, and I don't remember all of them, but I remember just enough to get started, and then slowly started learning new ones. So just learn the bare minimum, gradually learn from there. It's difficult, but that's the best I've got. Let's talk about more advanced insights, and I'm gonna focus on that sheet with the stock data. Okay, I'm going to ask the following question. I'm going to ask a bunch of questions, and I'm going to answer them with VisiData. So I'm going to ask, I want to know what day in 2017 had the biggest combined trade volume. Volume meaning how many stocks were bought or sold that day. And combined is in all the stocks that I've got together. I got like 20 companies here. All of them together, which day had the most activity in stocks? I actually don't remember how I did this, so I hope I will remember now. I want to add an aggregator to the volume column. So I'm going to go here and I'm going to press plus to add an aggregator. There are a bunch of aggregators, mean, max, average. I want sum. I want to sum it up. And I think I should go to the record date and do a frequency table. Yes, this gives me exactly what I want. Now I know for each day in 2017, what was the sum of the trade volume, and now I can just sort by that sum, and I can see the day that had the most trade, which is this day, I guess June 9th. And I can click on that, and I can see for that day exactly what the prices were and whether it was a happy high volume day or a sad high volume day. Or I guess it was happy for some of them. No, it looks like it was sad for everybody. So that was question number one. Again, feel free to interrupt if there are any questions or anything. Another question. Let's say that I want to know for each date, which stock went up in price the most, and by how much did it go up? So I've got a bunch of stock movements, and I want to add another column. I want to add another column that says for each day, and for each row, basically, how much did the stock go up by. I'm going to add a new column, and basically, I'm just writing a Python expression. Close minus open. And I even have auto-completion right in VisiData, divided by open. I'm going to call that change. And now I see the change for every row here. And now,
Can you do a relation between columns? Say the close of this column minus the close of the previous column?
good question. Good question. I had a need for that a few months ago, and I did it. I don't remember how though. I'm sorry. but this is something that people often request. But sorry, I don't remember. Talk to me later. We'll figure it out. So now I want to see for each day which company had the biggest change and what change there was. So I want to add an aggregator here for max, and I also want key max. Key max it's what you might call argmax. Key max gives me the key that produces the max. I think I need to set the company as a key column, I think. And then I'm going to do a frequency table on a date. Yeah, I'm not sure why I got the result 3 times, but I got the result. Now I have for each day, I get the company that had the biggest change and that change, right? First Xerox went out by 5%, then ESRX, whatever that is, went up by, I guess, 2%.
You got the volume sum.
Why I got the volume sum? Because I asked for it earlier and I didn't.
It's a remnant.
Yes, it's a remnant. I'm going to show you how to take it out. I can go to the columns sheet by pressing Shift-C, and I can see this now gives me a sheet of the column of my base sheet. So now I can go to, for each column, like the volume column, I can go and see the aggregators I've got for it, and I can edit this to remove the aggregator. And now if I'm going to do the same thing again, I won't have this remnant anymore. Very last question I'm going to answer. Let's say I want to focus on Apple, and I want to get a plot for the market cap of Apple for 2017. So let's focus on Apple. Right? Now I'm just on Apple. Everything here is Apple. And I can easily plot the stock price. Sorry. The stock price. Right? You've seen that before. But I want the market cap. And the market cap is the stock price times the number of outstanding shares. So I need the data for the outstanding shares. I don't have it in this sheet. But I have a separate sheet. Sorry. I have a separate sheet. And in that separate sheet, I have data for outstanding stocks in Apple. I want to combine the data from these 2 sheets. So I'm going to do a join. First, I'm gonna mark the record date as a key column, so VisiData will know on which column I'm doing the join. I got this sheet open. I'm going to go back to the previous sheet I had open, and now I'm going to press ampersand to do a join. There are a bunch of different options for joins. I'm going to pick the simplest one, which is inner. And now VisiData did a join for me. Now I've got a bunch of columns that I want to get rid of. I'm gonna, sorry, I accidentally exited. I'll try it again.
Join or you with the condition?
I barely know SQL, so it's a little bit tough for me to answer. But I did an inner join. There are a bunch of different options for joins. Let me show you. Got inner, outer, full, diff, append, concat, extend, merge. Again, I can't explain what these mean, but I know that they are there. So here's the inner join. I'm going to hide a bunch of columns that I don't care about. Okay, so now I've got the stock price and I've got the outstanding shares. Now it's very easy. I'm going to do a new column for the market cap is going to be just the open price times the outstanding shares. I'm going to call this market cap, and I'm going to plot it. And I'm done. Now I've got a plot for Apple's market cap in 2017.
Can you save the results in this format?
And you can save sort of like what's called a play log or a command log, and then it sort of saves all the commands for a sheet. I've never done this. I should do this, but I sort of never get around to it. But it doesn't really save the sheet. It saves like the base data and all of the commands you did in sequence.
So you can save the new table you just created.
Sorry?
You can save the market cap table.
Yes. Oh yeah. You can definitely always save a table. Like right now. Yes. Like right now, I was on a table, and I can just there's like a file save, and I can go and I can, save it as a CSV, whatever CSV, and it just saves it. Yeah, definitely. So this is pretty much everything I had to talk about. There's a bunch more insights that you can get from VisiData that I haven't gone into. I recommend the tutorial. I gave the link for the tutorial here, right? Really great tutorial. Just Google for JS VisiData and you'll find it. I'm going to stay here for, I guess, 5 more minutes to answer questions and stuff. This is VisiData site. Obviously, it's on GitHub. These are my slides. This is my research website, and this is my mailing list for monthly updates about my research. Thank you very much for listening.